Hi friends, enjoy your Sunday. Have faith in your heart and the courage to make all your dreams come true. One of the basic laws of fluid mechanics is conservation of mass. We will discuss this through the following problem. Fluid flow flows through a box that has many pipes. Well, we are asked to calculate the velocity of the fluid when the fluid flows out of one of the pipes. Previously we have known the Reynolds transport theorem. To analyze the mass of the fluid, the value of n is m, and the value of eta is 1. The important principle of conservation of mass is that there is no accumulation of mass in the selected control volume. So the mass of the system is constant. In other words, the rate of change of the mass of the system is 0. This is the formulation of conservation of mass. We will use this equation in our problem. Without waiting long, let's go to the discussion section. On the problem sheet, the cross-sectional area of each pipe has been given, as well as the flow velocity. There is also an identification of each part of the pipe. So we will use that identification as a reference. Just write the formulation of the law of conservation of mass. In this equation there is a quantity of density. There is no information related to this value. We usually simplify things. What if we assume that the flowing fluid is incompressible? The density is the same throughout. Rho has a constant value. This value can be excluded from the integral notation. We can cross it out. Take another look at the picture on the worksheet. We are going to define a control volume. The integral of 1 over the control volume is the volume of the control volume itself. The shape of the control volume is constant. This means that there is no change in the volume of the control volume. The derivative of the volume with respect to time is 0. Now this equation looks a lot simpler. We learned about uniform flow and non-uniform flow in the previous video. For uniform and steady flow, the integral notation can be changed to sigma notation. This is the final equation that we will use. Assuming that the flow is steady, incompressible, and uniform. The fluid can flow into, or flow out of the control volume. We are free to decide this. Let's say the fluid enters the control volume through pipe 1 and pipe 2. The fluid flows out through pipe 3. The direction of the arrow is also the direction of the fluid velocity. Now, draw the normal direction of the cross-sectional area of the pipe. I'm sure we're familiar with dot products. Well, sigma notation is the sum of the dot products of each pipe. For pipe 1, V1A1 is the cosine of 180 degrees. Because vectors A1 and V1 are in opposite directions. For pipe 2, V2A2 is the cosine of 180 degrees. For pipe 3, V3A3 is the cosine of 0 degrees. From the trigonometric table, the cosine of 0 degrees is 1. And the cosine of 180 degrees is -1. All of these values are listed on the problem sheet. Just substitute them. Using a scientific calculator, V3 is about 12.5 meters per second. This is the magnitude of the velocity. Velocity is a vector quantity that has a direction. We can write the vector v3 as v3 sine 30 I hat, plus v3 cosine 30 j hat. The sine of 30 degrees is half, the cosine of 30 degrees is half root 3. This value can be written as 25 over 4 times I hat plus root 3 j hat. This is the velocity of the fluid flowing out of pipe 3. Happy learning, everyone.
I feel this pain, you already know. Turn that to gains, let my money show. I've got these things that I can't let go. Watch me turn this life into something that you can never own.